Have you ever wondered what tiny creatures might be living in a puddle of water? Well, want to know more because you're looking at some on screen now. Many years ago, scientists wanted to know this too, and so they used lenses to magnify a drop of water, allowing us to see the world of single-celled organisms for the very first time. These early microscopes used a light source and one or more optical lenses to magnify an object. Today, we still use light microscopes to see objects that are too small to see with the naked eye. But we also use other types of microscopes, like electron microscopes and fluorescence microscopes, to see things that you can't see even with a light microscope. Microscopes that use light and optical lenses to magnify tiny objects are called light microscopes or optical microscopes. Light microscopes have been used for more than 400 years and are still the most common type of microscope in use today. In the 1600s, the Dutch biologist Antony van Leeuwenhoek developed a simple optical microscope which only had one lens and used the sun as a light source. Compound microscopes, light microscopes with more than one lens, had been invented in the 1500s but could only magnify up to 40 times. Leeuwenhoek's magnified over 200 times. He became the first scientist to see tiny single-celled organisms living in water, on his own teeth, in the bloodstream, and anywhere else he could think of. He called what he found animalcules, but we now know them to be protozoa, bacteria, blood cells, sperm cells, and the list goes on. Later, compound microscopes became more sophisticated and can now magnify objects much more than simple microscopes. Almost all light microscopes used today are compound microscopes. Most modern compound light microscopes have the same basic components. The first is an eyepiece containing an ocular lens. This is the part of the microscope that you look into, and it provides some magnification of the object you're looking at. Typical magnifications range from 2 times to 50 times. They also have an objective lens that is placed just above the object you want to magnify and magnifies the object even more. A light source illuminates the object, and a movable stage holds the sample and can be moved up and down using focusing knobs to bring the image into focus. A specialized type of optical microscope, called a fluorescence microscope, uses fluorescence to create an image. In a fluorescence microscope, specimens are first stained with a fluorescent dye that binds specifically to certain compounds in the specimen. Then, light at a single wavelength is used to cause the fluorescent dyes to give off light that can be picked up by a detector. Fluorescent microscopes are very useful in the life sciences, where they are used to visualize the expression of specific proteins or other molecules inside cells. Check out this image on screen. In this endothelial cell, fluorescence microscopy shows nuclei, which are stained blue, microtubules, which are stained green, and actin filaments, which are stained red. Both optical and fluorescence microscopes use light to create images, but there is another type of microscope called the electron microscope that uses a beam of electrons to image tiny objects and structures. Because the wavelength of an electron is much shorter than the wavelength of visible light waves, electron microscopes can achieve much higher magnifications that can't be seen even with an optical microscope. Electron microscopes are commonly used in the study of viruses and viral diagnoses, which were too small to study before. There are 2 types of electron microscopes. Number 1, a transmission electron microscope, or TEM, passes a beam of electrons through a very thin section of a specimen. The interaction of the electrons with the specimen is detected and used to create an image. Transmission electron microscopes have a very high resolution and can even allow you to see single atoms. This would never be possible with a light microscope. Number 2, instead of passing a beam of electrons through a specimen, a scanning electron microscope, or SEM, passes a beam of electrons over the surface of an object to create a 3-dimensional image. Although scanning electron microscopy does not have as much resolution as transmission electron microscopy, it can still image objects smaller than 1 nanometer. In addition, because scanning electron microscopy creates a 3D image, it can show surface structure better than any other type of microscopy. There are 3 general types of microscopes that can be used to visualize objects too small to see with the naked eye. Light or optical microscopes use optical lenses and a light source to magnify small specimens. Simple light microscopes use one lens, while compound light microscopes use more than one lens to create a magnified image. Fluorescence microscopes are a specialized type of optical microscope that creates images of fluorescent markers that are attached to specific proteins or compounds in a specimen. Electron microscopes use a beam of electrons instead of a beam of light to create an image. They have a much higher resolution than optical microscopes, but cannot create color images or identify specific compounds like fluorescence microscopes can. Transmission electron microscopes pass a beam of electrons through a very thin section of a specimen. Scanning electron microscopes pass a beam of electrons over a reflective surface to create three-dimensional images of very tiny objects.